It was late June, and the tomatoes nearest the walnut tree were dying. By the end of this, you'll see what that tree was doing to the soil for yards around, and why nothing sprayed on the leaves could stop it. The plants had been healthy all spring, then the ones closest to the big black walnut began to yellow, curl, and collapse from the top down. A gardener dug one up expecting rot, and found clean white roots, firm stems, no fungus, and no beetles. So someone lifted a dying tomato, carried it 30 feet past the edge of the walnut's canopy, and replanted it in ordinary soil. Within 2 weeks it stood back up, green and setting fruit. The same plant, the same summer, moved a few paces from one tree, and it lived. Whatever was killing the garden was not in the air or the seed. It was in the ground, and it had a range. The gardeners tried everything a gardener tries: fresh compost, more water, less water, fungicide, and the dead zone under the walnut only held its shape. The strangest part is not that the tree poisons its neighbors. It is how far that poison reaches and how long it lingers after the tree itself is gone. That dead ring in the soil was not a new mystery. People had been noticing it and misreading it for 2,000 years. Walk almost any old farmstead in the eastern United States, and you can find the same bare circle, a broad, spreading black walnut, and beneath it a strange emptiness where the tomatoes, the potatoes, the apple saplings, even the lilacs refuse to grow. Grass thins, vegetable rows fail. The tree itself stands untouched, wide and healthy, often over 100 years old, dropping its heavy green-husked nuts onto ground that seems to reject everything else. The Roman writer Pliny the Elder wrote in the 1st century that the shade of a walnut was poison and gave men headaches. And for centuries that was the explanation everyone accepted: bad shade, bad air. Farmers planted their gardens elsewhere and never asked why. But shade does not explain a dead tomato 30 feet out in full sun, past the last branch. And here is what almost no one expected. The tree is not defending itself by accident. What it does to the soil is closer to a weapon deliberately deployed, and the full range of it was only measured in the last 100 years. The place held the clue in plain sight. It needed someone to stop blaming the shade. The someone was a plant pathologist named Massey, working in Virginia in the 1920s. Farmers there kept reporting the same complaint. Healthy tomato and potato patches planted near black walnut trees would sicken and die within weeks. And in 1925, Massey decided to stop guessing and test it. He did not have much: garden plots, walnut trees of known size, and rows of tomato plants set at measured distances from the trunks. The method was almost brutally simple. Plant identical tomatoes at different distances from a black walnut, tend them all the same way, and watch which ones fell. If shade or root competition for water were the killer, the damage should fade gradually with distance and match the reach of the branches. If something else was at work, the pattern would betray it. Massey also dug. He traced walnut roots out through the soil, following them far past the edge of the canopy, mapping where the living roots actually reached versus where the shadow fell. He collected the wilted tomatoes and looked for any fungus or insect that could explain the deaths, and he found none. The same clean roots the gardeners had found. He was not looking for a chemical. Nobody was, yet. He was simply refusing to accept an answer that had stood, unquestioned, since Rome. What his measured rows showed next did not fit any of it. A black walnut kills tomatoes 50 feet away, out in full sun. When researchers finally mapped where the plants died, the dead zone was not a shadow, it was a circle. The tomatoes closest to the trunk went first. Then the ring of death spread outward, while past the last branch, into open sunlight where shade could never reach. So they dug and followed the tree's roots through the soil. The roots ran far beyond the canopy. A big black walnut spreads its roots 50 to 80 feet in every direction, more than twice the width of its own crown. The dead zone did not match the shade at all. It matched the roots exactly. That was the first crack in Pliny's 2,000-year-old answer. Whatever killed these gardens lived in the earth, spread by the walnut's own roots, and reached wherever they reached. But roots alone were not proof of a poison. Roots also drink water and pull nutrients from the ground, and a thirsty walnut could starve a tomato without any toxin at all. It was exactly the objection that would nearly sink the whole idea. The objection was obvious, and for a while it looked fatal. A large tree is thirsty. A black walnut this size can pull hundreds of gallons of water a day up through those far-reaching roots. And every root also strips nitrogen and minerals from the soil around it. Maybe the tomatoes were not being poisoned at all. Maybe they were simply being starved and dried out by a bigger, greedier plant. It was the kind of ordinary explanation that ends investigations. To break past it, the killer had to be separated from the tree entirely. So the test changed shape. Researchers took soil from beneath walnuts and grew tomatoes in it in pots, away from any living root. They soaked walnut roots, husks, and fallen leaves in water and poured only that water onto healthy, well-fed plants that wanted for nothing. If competition were the cause, these plants, with their own soil, their own water, no rival roots anywhere near, should have thrived. They did not. They wilted from the top down, the leaves browning at the edges, the stems going limp, exactly as they had under the living tree. Something in the walnut itself, carried in plain water, was doing the killing at concentrations as low as 1 part per million. It was not thirst. It was chemistry, and now they had to name it. A black walnut poisons the ground on purpose to kill anything that might compete with it. The weapon has a name, Juglone, a compound the tree manufactures in its leaves, its roots, and the green husks around its nuts. The walnut leaks Juglone into the soil constantly. Every fallen leaf, every rotting husk, every living root sheds it into the earth around the tree. For most plants, a trace of it is enough. Juglone attacks the victim from the inside, jamming the machinery its cells use to breathe and make energy, so the plant slowly suffocates where it stands, even with its roots in moist, fertile soil. That is why the tomato 30 feet out in full sun still died. Not shade, not thirst, but a poison the tree pumped into the ground to clear its own territory. Juglone was first pulled from walnut tissue and crystallized more than a century ago, but it took decades to accept that a tree could be waging chemical war on its neighbors. Scientists gave the strategy a name, allelopathy, one plant chemically suppressing another, and the black walnut became its most famous practitioner. And Juglone does not wash away quickly. It can linger in the soil for years, so a garden can stay poisoned long after the walnut that made it is cut down and hauled away. The dead ring under the walnut turned out to be one of the first clear cases of a plant fighting a chemical war, and once scientists knew to look, they found the same strategy everywhere. Sunflowers, certain grasses, and a long list of trees all quietly seed the ground around them with compounds that hold rivals back. The black walnut was simply the one that showed its hand most plainly, in a circle of dead tomatoes any gardener could see. Today the advice is practical and old at the same time. Keep your tomatoes, potatoes, peppers, and apples well clear of a black walnut, because the soil beneath it is not empty by accident. The tree cleared that ground on purpose, and it is still doing it, silently, through the roots, to anything that dares to grow too close.